So the experiment 7 is predictive parsing. So in compiler, predictive parsing is getting and grammatical syntax of a code. So the aim is to write a program to parse a given string using non-recursive predictive parsing for a given grammar. So this is the format. So it will get first from top down approach, it will get into recursive descent. So backtracking and non-backtracking will be happening. So in non-backtracking, predictive parsing and LR parsing will be happening right there. So this is the algorithm. So this is the algorithm. So set up IP to point of the first symbol of W. So let X to be the top of the stack and A the symbol point by the IP. So X is the terminal or core, then X is equal to A, then pop X from the stack. So advanced IP else error. So this is the sample input. So we need to give non-terminal inputs and the input symbols. So these are the inputs we have to give. So this is the following output code. It should generate the following output code like this. So this is the code. So in this process I have included buffer reader, input stream reader and array list, and then I am getting into scanner function. So class is array stack. In the array stack I have been using protected character of array. So in protected character of array I am having another class, another function. So in this function array stack is equal to size and array character size, and I am pushing the function here. So if top plus 1 is greater than size, then throw the exception. So if it's less than size, it will get into this function. So next one is pop. So in this pop function I am returning top minus. So push is to include a element in the file. Pop is to pop out the topmost element which in this file. So if you are having 3 4, so 4 will be popped out, so because it is in the topmost element. So I am getting into the main function. In this main function I am having two variables with the array list of alphabet and alpha. So I am reading this buffer reader. After that I am asking user to enter number of terminals. So number of terminals and the number of non-terminals in the grammar, and please enter all the terminals simultaneously. So this input process is big process, so it has lot of input need to be given. After that please enter all the non-terminal simultaneously. So after entering this, it will get into this following code. So enter the row entries of transaction table. So after functionating these row entries, it's going into give the input to the parser. So this is the input. So end your input with $# symbol character. So after that it's reading the array of stack, then it's calling the push function. So push state of 0, and then it's having an following output a stack input and output. So it's getting into while function up to this execute this hash. When it find this hash in the last of the terminal, you can see that hash and the dollar and hash is the terminating of this input. So when you see the dollar and hash, it should execute. Up to that it should execute the following function. So here I am using a display function. In this display function I am indicating the character and index of this thing and the character 2, and here I am popping out this function. Then if it is not there in this pop out, then it should show as null, then the given string is not accepted. Then I am having a transaction process. In this transaction process I am having a length value. So up to the length value it will execute a for function. Then it's having up to the length, it will have a push function. After push function it will get into this pop function. So if ch is equal to character of 3, up to that execution it will have this following execution function. Then ch is equal to dollar. So if ch is equal to dollar, push the next thing, else push the character of choice. If the input is equal to, if the last input is equal to dollar, so parsing completed successfully, and print do you want to continue or not. If continue means press 1 or else execute. So I am getting this input also with scanner, and I am reading with up to while is equal to 1. So if you are giving us 1, it will read. If you are giving us 0, it will execute. Then it's asking to enter the number. So the terminal is 6 and then on terminal is 5. So you can see the following input. And then a plus minus. The input process is a long process. Then I am supposed to do this row. So this following row has to be e is equal to ta and null, and this function has to be entered. After that this function has to be entered. So this is the long process. Then these function are to be entered. So after entering this, we need to enter the transaction table as this function. After that we need to enter the row transaction table as this function. Then we need to enter next values of this function. So we have entered the transaction row with following every commands with full input of non-terminals. Then given input to the parser. So in end of your input with this function, so I am ending this input with a plus a star a and star, a plus a star and a star. So start as this function. So it's according to the given input in the above, it should display this function, and it should display the stack, and it should display the input and output function, and after that it should say whether you need to continue or not. So this is the function. Because I have entered up to non-terminals here, so I need to enter the program and to execute it. So it will take time, just a minute. So I need to enter this transaction table and these functions. After entering this, I need to enter this these following functions also. I need to enter these following functions also. After entering this whole thing, you will get an input like this. So you can see the program I have executed has no error. So if you are giving an input, you will get an output like that. So because of this interruption in this file, I have explained that record in this code. I have explained that output in the code, remaining output in the code. So that's it for predictive parsing. Thank you.